so for our next topic, we'll cover laser naman. Okay? No, so last topic we had IRR. Now, let's go to laser. No, somehow medyo connected pa rin naman sila with the IRR. So, hindi masyadong mahirap yung transition in understanding the laser. Okay? So, laser stands for light amplification by stimulated emission of radiation. Okay? So, this is also an electromagnetic energy in or close to the visible range of the EMG spectrum. Okay? So, wavelength naman niya is between 500 and 1100 nanometer. Okay? While we have laser, no, may kita niyo din in your textbook, we also have maser. Okay? Si maser naman, kung kanina, light amplification, dito kasi, microwave naman yung gamit. Okay? So, this device used ammonia gas as its medium to produce stimulated emission of radiation in the microwave frequency range. That's why, no, may maser siya. Microwave amplification by stimulated emission of radiation. Okay, pero we will be focusing on the laser itself. No, ito medyo konting history lang. Okay, before we also had this one. Pero actually right now, parang laser na talaga yung pinaka ginagamit. Okay. So, we have what we call your high power laser. Okay, this is adopted for a range of medical applications, no? Like for example, by the ophthalmologists, okay, to weld detached retinas back in place. Okay, they use high power laser. Your surgeons naman, when finely controlled cutting and coagulation are required. No? Yeah. And then by the dermatologists for treating vascular lesions. Okay? So, yan. No? Pero hindi tayo under ophthalmologists, surgeons, or dermatologists. So, dun tayo mag-focus. Kung paano natin or how do we use laser. No? But definitely not high-powered ones. Okay? Aside from the medical applications, we have general uses of laser. No? We have scan barcodes, no? Laser yung ginagamit doon. No? Laser printer, yun na yung medyo mas mabilis yung printing. Your DVD and CD player. No? Although, ito medyo, alam ko, hindi na natin masyado ginagamit. Okay? Optical mouse. No? May kita nyo, di ba, parang may red light under the optical mouse. Okay, laser printer, mulit lang. And then for the industrial ones, welding and engraving. Okay, isa to sa mga sikat na use of laser. And of course, your surgeon. Okay. Now, let's further discuss laser itself. Okay. First would be the power and power density. Okay. Light intensity can be expressed in terms of power. No? When we say power, this is the rate of energy flow. No? This can be expressed in watts or milliwatts. Okay, we also have the power density. This is the amount of power naman per unit area. Okay, amount of power per unit area. Dito naman, we usually use milliwatts per cm squared or square centimeter. Okay, because laser can be too powerful. Okay, it was classified into 4. Okay, so ito yung mga classifications niya. You have class 1, 2, and 4. Okay, si class 3, hinati pa siya sa 2. Okay, so itong mga nakatakip, okay, these are just the most important ones, no? With your class 1 laser, okay, no hazard daw siya. Na ibig sabihin, kahit matutok yan sa'yo, walang irritation or walang harm that it might cause to you. Okay, that's your class 1. Class 2, this is safe for momentary viewing and will provoke a blink reflex. No? Blink reflex lang. Okay, and then for your 3A, okay, this is commonly used for laser pointers, poses an eye hazard with prolonged exposure. Kaya yung mga yung mga naglalaro, di ba? Dati, nung mga bata pa kayo, nilalaro-laro nyo yung laser, di ba? Pinagsasabihan tayo that we shouldn't be pointing it too long on the eye of our playmates, no? Kasi nga, it does pose an eye hazard with prolonged exposure. Okay? Your 3B naman, okay? This is the one that we use for physical therapy. Okay? However, this can cause permanent eye injury with brief exposure. Even with brief exposure, okay, it could cause permanent eye injury. So, medyo hazardous siya. Kaya yung the one that we are using for the rehab, okay, meron siyang pair of glasses, okay, to be used upon using the laser therapy. Okay? Sometimes, may mga students during pracs, before ng face-to-face pa, no, nakakalimutan nila that naka-on yung laser. Okay? Hindi, iaangat nila yung laser head, tapos pinopoint nila kung saan-saan. Okay? So, don't you ever forget na pag naka-on na yung laser, hindi nyo na dapat siya tinatapat kung saan. Dapat, it's supposed to be directed to the surface that needs to be exposed. Okay? Hindi nyo na siya ipopoint kung saan-saan. Right? Sabi, direct viewing of the beam should be avoided. Okay? Viewing of the diffuse beam reflected from the skin is safe, however. Okay? So, ibig sabihin, kapag ka-reflected siya from the skin, it's safe. Pero pagka reflected siya with the use of mirror, okay, yung mga yun, syempre hindi siya safe. Okay? So, from the skin lang ang safe. It can also cause minor skin burns with prolonged exposure. Okay? So, kaya meron tayong mga precautionary measures later on that we will be exercising or observing during the application of the laser. Okay? And lastly would be your class 4. Okay? With a power of greater than 500 milliwatts. Okay? Si class 4, this is the one that is used in your surgical and industrial cutting lasers. Okay? And just as before, no, with your 3B, no, carry over lang yung other effects that it could cause permanent eye injury, it can cause burns, it can actually cause din ng burn clothing and should be used with extreme caution. Okay? Yung di-discuss natin, okay, we will be focusing here in your class 3. So, aside from power, now we will be much familiar with energy and energy density. Okay? Energy is the power multiplied by the time of application and is measured in joules. Okay, we also have the energy density, no? Pagka nilalagyan na natin ng unit area, doon na siya nagiging density. Yun lang yung tatandaan niyo. Okay? Just like with your power density. Okay? Si energy density naman, this is the amount of power per unit area. Okay? Amount of power per unit area. Para hindi kayo malilito kay power density, balikan natin konti. With your power density, ay amount of power per unit area, and we are using the milliwatts per square centimeter. Okay, milliwatts per square centimeter. Okay, while your energy density, okay, amount of power per unit area, but we are using the joules per square centimeter. Okay, joules per square centimeter. Okay, si joules naman, no, ito yung iti-take note ninyo kasi some of the students during the computation, no, dito mag-i-include, meron na kasing ang nadagdag dito would be yung computations. Okay, we will be having computations here, so kailangan meron kayong calculator ready for post-quiz later. Okay, so energy, okay, is measured in joules. Okay, so para hindi kayo magkamali sa quiz later, tatandaan niyo that your joules, okay, is equal to the power times time. Okay? Power times the time. Right? Power times the time would be equal to your joule. Okay? And your energy density would be consisting of the joule per square centimeter. So, even though they have the same definition, okay, na amount of power per unit area, they rely on different measurement. Okay? So, yung si power density, it's power divided by, milliwatt divided by the square centimeter. Okay? So, ibig sabihin, power divided by the area. Okay? So, yung energy density, wag malilito. Okay? This is coming from the product of the power and the time of application. Okay? So, si power density at energy density, magkaiba sila. Okay? Magkaiba sila. Okay? Ayan. Therefore, in your energy density, ito nga siya. Okay, joules, and then area of irradiation, or the area where you will be applying the laser. Okay? Ayan. So, joules per square centimeter. Okay, now, we also have the low-level laser. Ito yung ginagamit natin in rehab. Okay? With your helium neon, okay, this stimulates tissue healing. Okay? Your helium neon is used as the treatment of choice for a wide range of conditions. Okay? So this just an example of your laser. No? This is how it looks like. No? Yung laser head, this one, okay, almost the same siya of how the ultrasound head looks like. Okay? So, wag malilito when faced with a machine for laser and machine for ultrasound, because what we have in the school, no, is almost look alike sila kasi parehas sila ng adjustments ng mga buttons. Okay? Parehas sila. But, of course, kung titingnan nyo mabuti yung machine, okay, may kita nyo merong pang detect ng laser. Okay? Obviously, you are dealing with a laser machine. Okay? Importante that you have to recognize that, okay, para lang maiwasan natin na mamaya i-on nyo yung machine, yun pala, laser siya, and you thought it was ultrasound, no? Just for your precautionary measures. Okay? Physical principles. Okay? One of the physical principles of your laser is the spontaneous emission of radiation. Okay? Spontaneous emission of radiation. Okay? So this produces light in non-laser sources, okay, and stimulation of atoms and molecules so that the electrons will shift to a higher energy orbits. Okay? So whenever they shift to a higher energy orbits, okay, they produce certain waves. And you know it that when we have these waves, okay, it means that there is radiation. And when there is radiation, there is heat. Okay? Merong heat. Right? Next, okay? Absorption of radiation. Okay. So, this occurs when a photon of light interacts with an atom or molecule is equals the energy carried by the photon. Okay? Absorption is said to be wavelength specific. No? Ito na naman yung, di ba, from our last discussion, we said that the IRR is exempted from the FWAP that I have discussed before, no? Yung mnemonic na FWAP. Okay? Si laser, no, babalik natin siya, no? Applicable kay laser yung mnemonic. Okay? So, ibig sabihin, if you have a shorter wavelength, then you have increased absorption and lower penetration. Okay? And then vice versa. The production of stimulated emission. So, paano ba natin na-produce yung laser itself? Okay? So, of course, we will be needing these properties. Okay? We will be needing these structures. Okay? First one would be your lacing medium. Very important. No? pinakauna would be your lacing medium. Okay? Your lacing medium should be capable of being pumped with energy to produce stimulated emission. Now, we have numbers of lacing medium. Now, we have helium-neon. Okay, so nabanggit natin siya kanina, no, that it is very useful for tissue healing. Okay, so your helium-neon is a gaseous mixture of helium-neon itself. Okay, so kaya Hene. Okay, and then we also have gas. Okay, this is a mixture naman of gallium arsenide. Okay, and then lastly would be the Gaias semiconductors. Okay, this is a mixture naman of your gallium, aluminum, arsenide. Okay, gallium, aluminum, arsenide. In your helium-neon, no, it has a 632.8 nanometer. Okay, while your numbers 2 and 3 lacing medium, they produce radiation at about 630 to 950 nanometer. Okay, 630 to 950 nanometer. No, this is the huwag niyong kakalimutan ha, this is the wavelength, no? So knowing that you have a shorter wavelength kay helium-neon, tapos mas mahaba, okay, or longer ang wavelength of your gas, okay, and your Gaia semiconductors. Okay, it just means that, okay, increase or longer ang wavelength, okay, lesser ang absorption. Okay, and then increase ang penetration. Okay, so mas kayang mag-penetrate nito numbers 2 and 3 na lacing medium versus your helium-neon. Okay, but when you compare it with your IRR versus this lacing mediums, no, syempre, you would have a deeper penetration using these mediums than using the IRR. Okay? It's just that pagka kinumpare na natin between the lacing mediums itself, okay, mas deeper pagka yung 2M. Okay, so medyo mapapansin nyo na parang kinut ko yung video, no? I just had to edit this, no? May correction from that last frame na nakita nyo. So this one's the corrected slide. Okay, so helium-neon versus your gas. Okay, si gas kasi and your gas semiconductor, no, somehow they are quite similar. Okay, so what we are going to compare is your helium-neon versus your gas. Okay, so si helium-neon, nabubulol na ako. Okay, it emits red light. Okay, while your gas emits infrared radiation. Okay, of course, when in terms of the frequency, no, applying your FWAP mnemonic, no, since you have a shorter wavelength for your helium-neon, automatically that would mean that you have a higher frequency when compared to the gas, no, which would have a lower frequency because of the increase in wavelength. Okay, and then for your helium-neon, no, this is absorbed in superficial structures. Okay, kasi nga, 'di ba? Higher frequency, okay? Shorter ang wavelength. Okay? And then dahil alternate siya, 'di ba? Increase ang absorption. Okay? Therefore, absorbed in superficial structures, no? Kasi increase nga yung absorption niya. More on targeted niya is the superficial structures than the deeper ones. Okay? And then your gas would be vice versa na lang. Okay? So next would be the resonating cavity or chamber. Okay? So resonating cavity or chamber, this would consist of a structure to contain the lacing medium and with a pair of parallel reflecting surfaces or mirrors. No? So of course, we would need a, when we say cavity or chamber, it means an empty space. Okay? So ito siya. No? This one that you see in the picture. Okay? And then, the lacing medium here Okay? Yan siya. Okay? In which, in the picture, no, naka-label as flash tube. Okay? Flash tube. Okay, so dyan naka-contain yung lacing medium. Alright? So, your resonating cavity chamber, no, comes with a pair of parallel reflecting surfaces, or what we call the mirrors, no? Merong mirrored surface here and merong partially mirrored surface here. No, why do we have that? Okay? As we hit the flash tube kasi, no, or the lacing medium, no, we pumped it with energy, it emits radiation, no? Once it emits radiation, it will produce light. Okay? Yung na-produce na light na yun, no, will yung na-produce na light na yun will reflect dun sa mirror, no? It will reflect back and forth hanggang sa ma-amplify yung light. Okay? That's why we call this laser as light amplification. Okay? By stimulation of emitted radiation. Okay? Kung mapapansin ninyo, partially mirrored surface lang yung one end. Okay? Because if it's not a pure mirror like we have here on this end, it won't reflect 100%. No? Some would be allowed to pass through. No? Siyempre, kailangan natin palabasin yung light na yun para meron tayong ma-reflect na laser. Para merong lalabas na laser, or else, nandun lang sila sa loob. Okay, nandun lang sila sa loob. So, therefore, this one's partially mirrored surface, while the other one is a pure mirror. No? Para siya yung talagang magre-reflect. No? Para ang direction of the light would be unidirectional, which is going here. Okay? Next. Okay? Siyempre, kung may lacing medium tayo, meron na siyang lalagyanan, which is your resonating cavity or chamber, we would also have the power source. No? This would be the one that will be pumping the lacing medium to produce stimulated emission. Okay? So, power source. Now, let's talk about the characteristics of your laser. What makes it unique from the other modalities? Okay? Tatlo lang ang kailangan nyo tandaan. It's monochromatic, it's coherent, and it's directional. Okay? Directional or collimation. Let's have the monochromaticity first. Okay? When we say mono, it means one. Okay? When we say chromaticity, it means we're talking about colors. No? So, monochromaticity, it means single color. No? Single color produced. Ibig sabihin, when you emit that radiation and it produces light, okay, it will produce one light only. No? Hindi siya paiba-iba ng color. Okay? Kung red, red lang. Okay? Kung blue, blue lang. Okay? But, as per the laser, no, it's more of red. Okay? So, single wavelength with a very narrow bandwidth. Okay? When we say wavelength, no, a critical factor in determining the biological effects produced by your laser treatments. Okay? The wavelength determines which molecules will absorb the incident radiation. Okay, kaya per wavelength natin, no, kung mapapansin nyo, there's a difference from the wavelength of IRR and then now going to laser. No, diba? Thousands ang inaabot with your IRR. Okay? Na wavelength. But here, no, we have been discussing, no, it's around 600 plus to 900 plus nanometers. Because, again, the wavelength determines which molecules will absorb the incident radiation. So, somehow, merong pagkakaiba sila ng indication. Okay? Next is your coherence. Okay? The throws and peaks of the emitted light waves match perfectly in time and in space. Now, we have a picture here, I believe. Okay? Next slides natin para lang ma-appreciate. Okay? That's your coherent. No? Ibig sabihin daw, both in time and in space, sabay-sabay sila. Okay? Ng waves. Okay? Yan yung coherent na sinasabi natin. Okay? And yan ang characteristic ng laser. Okay? So, it has both the temporal coherence and your spatial coherence. May timing, and in space, no, match na match yung kanilang produced light waves. Okay? Or emitted light waves. Lastly would be your collimation or direction. Okay, sabi dito, it keeps the optical power of the device bundled onto a relatively small area over considerable distances. Okay? But this one naman, okay, di ba before, ang nagiging problem natin kay IRR, ang hirap niyang itutok. No? It's hard to localize which area do you really want to expose, okay, with the radiation. But with your laser, no, pansin nyo naman, kahit yung mga laser na nilalaro-laro nyo lang before, no, like, pwede nyo siyang i-point anywhere and hindi makalat yung light. Okay? Highly collimated courses are more dangerous to unprotected eye. No? Kaya siya yung ating class 3B that is used for therapy na laser, no? Hindi siya po pwede kahit saglit lang or brief exposure to eye, no? It could cause a permanent eye injury. So, we should extremely practice yung mga precautionary measures, no? Observe the precautionary measures. Okay? So, kung tutuusin, no? Parang ganito siya. This is your laser. Versus your LED. Okay? Versus your LED. Okay, kung makikita nyo doon, no? Ayan. This is the laser. Okay? It's directional. Okay? Hindi siya ganito, no? Parang ganito sa IRR. Pakalat. Okay? But with your laser, it's directional. Okay? It's easy to point. Okay? Wala masyadong divergence. Okay? This is just a comparison of your LED, SLB, and laser. No? Si laser, mas localized siya. Okay? Si LED, your light-emitting diode, okay? Parang laser din siya, pero wala siya nung property of collimation. Okay, hindi siya directional. No? It's pretty divergent. Now, let's discuss naman yung laser-tissue interaction. Okay? Yeah. Scattering of incident light. Okay? This is the change in the direction of propagation of the light as it passes through the tissues. No, although we have discussed na directional siya, diretso yung kanyang diretso yung orientation of the light. No, once it passes through the tissues, it widens. Okay, underneath it widens. Okay, and there is a rapid loss of coherence. Merong rapid loss of coherence. So, kumbaga, parang kumakalat siya sa loob. Alright? Yung picture sa kanina, this is just to, compare the spread of light between LED, SLB, and laser. Okay? Pero hindi yan yung pagka nilagay na natin sa skin. No? It's different. No? Pag nilagay na natin siya sa skin, katutok na siya. Alright? Medyo nag-dissipate na siya dun sa ilalim. No? Medyo nag-scatter na siya. No? That's a better term. Scatter. Okay, next. Absorption of incident light by a chromophore. Okay? Chromophore is a biomolecule that is capable of absorbing incident photons. No? Like for example, your melanin and hemoglobin. Okay? Ibig sabihin, if we have this, what we call your chromophore, in the past, we had the IRR. We said that a higher absorption coefficient means that it can absorb more energy from the IRR. Meaning, kapag meron kang darker skin and darker tissue, you have a higher tendency to absorb the energy more. Okay? When you compare it to the people who have a fairer skin and lighter tissue. Okay? Actually, same goes with your laser, no? Medyo binigyan lang natin siya ng pinaka-term, which is your chromophore. Okay? Kasi in your chromophore, you have the melanin and hemoglobin. Okay, it's quite same with what we had in IRR. It's just that here, no, kasi si melanin siya yung nagpa-produce ng dark pigmentation. And sa people with dark skin, no, meron silang increased number of melanin. Okay, or let's say mas active ang melanin nila. No? Let me correct that. Mas active ang melanin nila. Alright? And then hemoglobin. This is all over the body. So, we have no problem dun sa parts of the body na baka hindi siya maka-absorb ng energy coming from the laser, no? Because, ibig sabihin lang nito, if it's rich, if there is a good blood circulation, okay, on that certain part of the body, okay, then meron tayong capable of absorbing incident photons coming from the laser. Okay. However, the penetration depth is no more than several millimeters. So, ibig sabihin, somehow, medyo superficial pa rin siya. Okay, absorption is dependent upon the wavelength of the incident light. The depth of penetration is similarly wavelength dependent. No? Again, katulad ng na-discuss natin before, no? Yung WAP na mnemonic. Okay? It will apply. Okay, so sana naalala niyo pa si ARNDT-SCHULTZ law. Okay? So, too little energy have no measurable effect. Too much being damaging. No? Kaya meron tayong classifications, di ba? And then, while energy levels between these extremes can be therapeutic. Okay? So, therapeutic siya. Yan. So, if we have weak stimulus, okay, it activates biological functions, no? Once we apply the ARNDT-SCHULTZ law in laser, no, weak stimulus activates biological functions. Medium stimulus, it modulates the biological functions. Strong stimulus may inhibit the biological functions, while very strong stimulus may block the biological functions. Okay? Yan siya. So, usually, ito yung pinaka mas applied sa ating modalities. No? We modulate the biological functions. Okay? So, sabi nga, no, para ma-reach natin yung therapeutic level, or the therapeutic effect, we should stay in 50, no, according to your ARNDT-SCHULTZ. Principles of clinical applications. Right? You have indications. Okay? Saan indicated ang laser? Wound management, soft tissue injuries, arthritic conditions, and your pain relief. Okay? Now, your laser, no, it's completely different with IRR. Diba? Kay IRR, we just manage kung we just monitor how close it is from the patient, okay, or how close it is to the patient, okay, and then 20 minutes, bare months duration, okay na. But with your laser, this is the unique, another unique thing about it. The dosage and irradiation parameters. No, you have to compute for the dosage. So these are your bases, no? Power output, irradiance, energy, radiant exposure, and your pulse repetition rate. Okay, let's discuss first your power output. Okay, so sa power output, the unit of measurement is milliwatts. So this one is fixed and invariable. No, usually may kita nyo siya dun sa machine na. No? Nakalagay na doon kung ilan yung milliwatts niya. Okay? Siyempre, pagka higher yung milliwatts, meaning mas mahal. Okay? And syempre, pagka higher ang power, okay, you can deliver the specific treatment in a shorter duration. Okay? Yun lang ang pinagkaiba nila. Okay? So, higher power meaning shorter duration. Okay? Irradiance, okay, or your power density. Okay? Kung matatandaan niyo, this is power over the area. Okay, ang unit of measurement natin dito would be milliwatts per square centimeters. Okay, most commonly used for the area would be 0.1 to 0.125 square centimeter. Okay, for the area, this is most commonly used, okay, in the clinics. Okay, this is kept as high as possible by applying a firm pressure through the treatment head during treatment. This is what we call the in-contact technique. Okay? In-contact technique. Actually, in our lab, ito yung dinemo ko, no? The in-contact technique. But, I wasn't able to demo na yung, yung non-contact. Okay? Pero kasi, somehow, parehas lang naman eh. Ang nagkaiba lang, contact yung isa naman, hindi mo siya kinontact sa skin. No? Out contact will reduce the effectiveness of the treatment. Okay? So, preferably, yung in-contact technique tayo. Kailan lang natin ginagamit yung out-contact na sinasabi niya or yung non-contact. Okay? This is during treatment of your wounds. Okay? Hindi mo naman siya pwedeng firmly pa-pressure mo siya dun sa wound. Siya masakit din sa patient. Okay? Or baka mo-contaminate yung device, no? Especially ngayon na pandemic. Okay? So, sa mga scenarios na yon, hindi natin siya directly kino-contact dun sa skin or dun sa surface. But there is a certain cutoff lang na dapat it shouldn't be farther than that. Else, there wouldn't be any effect na. Okay? Energy, no? Again, ito yung kanina pa nating pinag-uusapan, unit of measurement would be in joules. Okay? So, paalala lang natin, no? Power output, okay? Your joules or energy is the product of the power output and the time of irradiation. Okay? Like, for example, no? 30 milliwatts applied for 1 minute. Okay? Try nyo siyang i-compute. Alright? Try nyo siyang i-compute and then pause nyo muna yung video and then you'll tingnan natin kung tama yung kinompute nyo. So, start. 30 milliwatts, that would be the power output, times the time of irradiation would be 1 minute. Okay? Okay, let's see kung tama yung inyong computation. Alright? So, ang sabi, this will deliver 1.8 joules of energy. No? So, bakit naging 1.8, ma'am? Okay. Kasi, diba, if kung maalala ninyo, okay, your power output in computation for the energy should be in watts. Okay? It should be in watts. Therefore, kailangan nyo ito i-convert into watts, yung 30 milliwatts. Okay? And then, time of irradiation, kailangan ang unit of measurement niya should be in seconds. Okay? So, if it's in seconds, ang 1 minute nyo magiging 60 seconds. Okay? And then, 30 milliwatts. So, meaning, you have to divide it by 1,000. Okay? 30 divided by 1,000, so that would be, okay, if I'm not mistaken, that would be 0.03. Okay, tapos compute natin. Okay, so tama, no? 0.03 times 60. Okay, so pwede nyo siyang itry sa, sa mga sarili-sarili nyong calculators para ma-check natin, no? That would mean, okay, that would be equal to 1.8 joules, no? So, try nyo ulit, no, with the next example here, no? Pause nyo ulit, and then, check natin kung lalabas ba siya na 3 joules talaga. Okay? So, pag dinivide nyo siya over 1,000, okay, 100 divided by 1,000, that would be 0.1. Okay? And then, diretso nyo na siya, no? Kasi since naka-seconds na siya, okay, diretso nyo na times 30. Okay? So, that would be 3 joules per point. No? Kaya sinasabing per point, okay, kasi, di ba, again, we will be using the in contact technique. Okay? So, yun yung sinasabi niyang 3 joules per point. Okay? So, i-adjust niyo yung machine, no, into 3 joules. Okay? Tapos, after nun, no, tutunog naman siya, may timer yun. Okay? And then, ayun. No? Ayan. So, per point yung delivery ng treatment. Okay? Next would be your radiant exposure, okay, or your energy density. The unit of measurement naman would be joules per square centimeter. Okay? This is the best means of specifying a dosage. Okay? Ito talaga yung pinaka-dosage natin, no, when we are talking about laser. Okay? So, for treatment, it may range from 1 to 30 joules per square centimeters. Okay? So, it would, again, it would mean energy divided by the size of treatment unit. Okay? Ayan. So, for example, no? Treatment of the cubitus ulcer. Okay? Treatment of the cubitus ulcer, we have 500 milliwatts. Okay? For your power. And then, time of irradiation would be 2 minutes over a 12 square centimeter, okay, na wound. Alright? So, using the formula here, no, energy divided by the size of treatment unit, okay, we will get the answer of 5 joules per cm squared. No? Para medyo ma-practice nyo na siya, alam ko na meron siyang answer na agad. So, hindi ko kasi na-edit yung animation, no? But, you should try it for yourself. How would you arrive with a 5 joules per centimeter? Some students kasi, they underestimate no, na parang madali lang naman. Okay? So, hindi siya actually madali. For the past semesters and na nagtuturo ako ng PEA, some students don't get it at first. So, you really have to practice. How did we arrive with 5 joules per square centimeter? No? So, let me just help you with that. Okay. 500 milliwatts. Okay, kailangan, again, we should convert this into watts. So, 500 divided by 1,000. Okay, that would be 0.5 watts. Okay, and then yung minutes, gagawin natin siyang seconds. Okay, so to get the energy here, you should multiply the power into the time of irradiation, okay, which would be 0.5, okay, times 120 seconds. Okay, so that would mean 60. And then we, sabi dito na energy divided by size of treatment unit. Since we have 12 here, and square centimeter talaga ang measurement niya, unit of measurement niya, then we directly divide 60 divided by 12. Okay, then we'll arrive with 5 joules per square centimeter. Okay, so in our post-quiz, don't forget to use the correct unit. Okay, kung joules man yan, milliwatts man yan, watts, seconds, okay, and should be in capital, no, kapag ka pina-identify sa inyo yung mismong sagot. Okay, yung yan. Pero, I would allow you ano na siya, abrev, no? Instead na joules na buo, pwedeng J na lang. Tapos, ayan, J over cm squared. No? Yung cm, ganun pa din. Dapat naka-all capital. Okay? Pagka pina-identify ko sa inyo yung certain question. Okay? So, you have to practice this, no? Because aside from the energy density, okay, or the dosage, no? Pag sinabi natin, what is the dosage? It means I'm asking for the energy density. Okay? I'm asking for the energy density. Okay? So, hindi lang energy density yung pwede kong itanong. I could be giving you the energy density na agad. I might give you the energy itself, and then i-ask ko kayo, what is the size of the treatment unit? Okay? So, paano natin gagawin yon? No? If you can remember, no, sa inyong math before, yung transposing, okay, meaning, di ba, this is energy density equals to energy over the size of treatment unit. Okay? So, with the power of transposing, I think I would have to demonstrate that to you. Baka mabuluhan kayo. Okay? Ano lang tayo ng ayan. Lagay lang tayo na we need just a little space. So, pagpasansyahan nyo na, if in case pangit yung wait. Right there. Okay? So, as I have told you, no, the energy density is equal to the energy divided by the size. Okay? But I might also be asking you to determine the size itself. So, when we say transposing, ibig sabihin, we are switching sides. Okay? And whenever we switch to the other side, okay, yung kaninang nasa baba, which is your size, okay, pwede na siyang dun sa taas. Okay? Like for example, this one, energy over size. When size goes here, no, it wouldn't be energy density over size. Hindi na siya ganon. Okay? But it would be placed, okay, the same with the energy density. Nasa, ano ba yung tawag sa math neto? Yung nasa ibabaw. Okay? I'm not sure with the term. No? Pero hindi na siya under. Okay? So, it would become like this, no? Size. Okay? If I'm asking for the size, you would need to transpose that para nandito siya sa taas. Okay? Para makuha natin yung whole number. Okay? Kaya natin siya transpose yan. And syempre, dahil I'm asking for the size only, we would have to remove the energy density here. Okay? So, ma-migrate naman siya sa kabila. Okay? That would mean energy, dahil hindi naman nag-switch ng side si energy, nag-stay lang siya dyan. Okay? Sa energy density before, nasa taas siya. Ngayon, dahil nag-switch siya ng sides, nasa baba na siya. So, energy over energy density. I hope you got that. Okay? Ayan. Energy over energy density. Okay? So, ganyan. Alright? I might be asking the time of irradiation itself. No, papaano yun, ma'am? Okay? Diba, energy density is equal to energy over size. Your energy is actually, no, pwede nating pahabain yan. No? Instead of energy density, gawin ko na lang ha. Okay? Your energy is computed as the product of the power times the time of irradiation over size. No? Medyo pinahaba lang natin, but energy is also equal to this. Okay, medyo breakdown lang natin ng konti. So, if I'm asking for the time, we would have to transpose all over again. No? So, si size, pupunta siya dito. since nasa ilalim siya, mapupunta siya sa ibabaw dito. So, ED times the size. Okay? Since time lang yung ina-ask ko, yung power, lilipat din siya to the other side. Okay? And since si power, nasa taas siya at this side, if it goes towards the ED's side, okay, it would be under na. Okay? Ayan. And then, equal to time. Alright? Please take time to understand this, no? Rather than take down note of the formula, no? Maguguluhan lang yung utak nyo kasi pag nakalimutan nyo, hindi nyo na alam paano aayusin, no? So, yung time, since I'm asking for that, no, nagstay lang siya dyan, no? Para maging whole number. Okay? Since nasa taas si power, okay, nasa taas siya, okay, when we transpose it to the other side, no, naging ED times size divided by power. Okay, I hope you got that, no? Kasi nakaganito siya eh, but if drino kasi natin siya, ang mangyayari dyan, no, para ang nangyari would be ED so pinapahirapan ko yung ED size, baka kasi merong mga nalilito eh kung ano yung taas pa ba na sinasabi ko. ED size and then power, okay, effort and then the time. Okay, so you notice, no, every time that we transpose, no, from side then to the other side, no, mapupunta sa baba. Of course, itong size, pag binalik natin dito, mapupunta siya sa baba. Okay, over size. Ganon. Okay? Ito, nire-write ko lang siya into this para lang yung iba, no, magigets kung ano yung sinasabi kong baba, taas, kanina. Okay? So, yun siya. Alright? Yeah. Next, let's discuss the pulse repetition rate. No, if naguguluhan pa din kayo, you can take time to practice. Okay, para may ma-answer kayo sa post-quiz later. Okay. So most outputs are continuous. Okay. So unit of measurement for your pulse repetition rate would be your hertz or pulse per second. Okay, or your PPS. No, so it means we are talking about frequency. Okay? Actually, yung pulse per rate nyo, hindi nyo siya magiging problem. Kasi, hindi ko na siya pinapa-adjust doon sa machine. Okay? So, basta, what I want you to practice here is how to compute for the dosage. Okay? How to compute for the dosage. Okay? Ito yung sinasabi natin kanina na contact versus non-contact technique. Okay? Ito si non-contact, and then this is your contact technique. Okay? Yan. And usually we do this, no, kapag merong wounds, no, to avoid contamination. So speaking of wounds, no, treatment of open wounds and ulcers. Okay? If it's the wound margin, no, when we say wound margin, yung edges. Okay, edges lang ng wound. Okay, hindi yung wound itself. Just the edges. Okay, around the wound. Okay, we use the single diode probe. Okay, when we say single diode probe, okay, ito kasi yung madaling palitan lang, no? Madaling i-disinfect lang. We apply it around the circumference at approximately 1 to 2 centimeters from its edges. Na ibig sabihin, if it's the wound margin, a little bit away from it pa. No, 1 to 2 centimeters. Okay? 1 to 2 centimeters. Points of application. Okay? This should be no more than 2 to 3 centimeters apart. No? So, para lang medyo ma-picture out nyo siya. No? Drawing tayo ulit ng konti. Okay? Oval. So, for example, this is the wound. Okay? Ang sabi, you should apply it around the circumference at about approximately 1 to 2 centimeters from its edges. So, kunwari, dito yon. Ay, pangit yung drawing. Paano i-undo? Ay, ayun. Hala. Ulit tayo. Ayan yung wound. And then, 1 to 2 centimeters from its edges. For example, ito yon. So, dyan nyo i-apply. Okay? Pero ang laser, no, ang application niya is per point. Ibig sabihin, hindi nyo iniikot yan. Okay? Wala akong makikita ang student na mag-iikot ng laser. Okay? Hindi iniikot ang laser. You just point it. Okay? Stay there for few seconds or minutes. And then after that, you point it again. Okay? Yung point na sinasabi na yun, ito yung points of application. So, meaning, right, dapat daw should be no more than 2 to 3 centimeters apart. Ibig sabihin, pag nag-apply ka dito, no, ang next application mo is around here. Okay? And then, next application mo around here. Hanggang sa makompleto mo yung buong circle na yan. Okay? Dapat dito yan ha, sa bandang black area. Pero di nyo kasi ma-appreciate yung color. Kaya dito ko nilagay medyo labas. Okay? So, ayan. Yung distance ng bawat points should be no more than 2 to 3 centimeters apart. Yun yung sinasabi natin. Okay? Ayan. Next. Okay? So, there should be a firm pressure to intact skin within patient's tolerance. No? Huwag may sobrang parang nasasaktan na si patient. Just firm enough, no, para ma-deliver nyo yung energy doon sa target natin. Okay? So, the dosage for this is 1 joule per point. So, approximately, you have 10 joules per cm squared. No? Assuming that you have 0.1 square centimeter spot size of the wound margin. Okay? So, ibig sabihin, bawat point na yun, no, 1 joule per point. 1 joule per point. 1 joule per point. Assuming that you have a 0.1 square centimeter spot size. Okay? Now, paano naman pag kayo mismong wound bed na? Okay, kanina dun tayo sa gilid. Now, let's go to the center, the wound itself. Okay? Dito, we use the non-contact technique. Okay? And we have a lower dosage, no? Because this is a radiant exposure with 1 to 10 joules per square centimeters. No? Most commonly recommended is the Mester protocol na sinasabi. Okay? So, ibig sabihin, pag nakita niyo sa exam, yung Mester protocol. Okay? Ang ibig sabihin nun, meron na kayong dosage agad, which is 4 joules per square centimeters. Okay? Now, maintaining a distance of no more than 1 centimeter from the wounded. Ibig sabihin, even if it's non-contact, it should be as close as possible. No? Sabi, no more than 1 centimeter from the wounded. No? Yeah. Okay, so this is just a picture. So, yung treatment over the wound margin, no? Parang ganyan. May picture pala tayo dito. Nagpakahirap pa ako kanina. Okay, I forgot. Yan yung certain points. No? Kunwari, 30 seconds dito, 30 seconds dito, 30 seconds dito. Depende dun sa dosage na makakompute. Okay. Now, for your for wound bed itself naman, no, pwedeng ganito yung point of application. Okay? If it's too big, ganun pa din, no more than 2 to 3 centimeter apart. Okay. Treatment of other conditions. Okay? You have trigger points, irradiation over nerve roots. Okay? I-discuss natin ito pagdating natin sa lab. Okay? Soft tissue injuries. Okay? Neuropathic and neurogenic pain. Arthrogenic pain and arthritis. Okay? And then, according to condition, okay, for superficial, we have the visible red laser, infrared laser for deep, and for the acute low pulse frequency or long pulse duration, and chronic naman, high frequency short pulse durations. Okay? So, these are the suggested treatment dose. Okay? So, ito dapat medyo alam niyo pa. Let's go to the hazards. Okay, contraindications, no? Again, malignancy or your active or suspected carcinoma. Pregnancy, okay, applies, no? Unlike your IRR, no, walang nabanggit about pregnancy, but with your laser, kailangan contraindicated siya. Direct irradiation over na pregnant uterus. No? Pag sa uterus lang. Pero pag kunwari si patient nyo, paalang naman yung kailangan nyo i-treat with the laser, okay lang. Okay? Irradiation of the testes, no? Hindi pwede. No? Baka malito. Areas of hemorrhage, okay? Because you might further cause injury. Direct irradiation over the eyes, obviously, no? Kasi it will cause permanent eye injury. Okay? Over thyroid or other endocrine glands. Okay? And recently exposed to radiotherapy. Okay, kasi madali silang ma-burn or just like your IRR, they have lesser appreciation of they have lesser sensory appreciation. So, medyo mas high yung tendency baka ma-burn sila. Precautions. Okay. Treatment of infected tissue. Treatment over sympathetic ganglia, vagus nerves, and cardiac region in patients with heart disease. Okay? So, hindi, medyo perform tayong precautions dyan. And when we say precautions, we should constantly ask the patient kung meron ba silang nararamdaman or meron bang napapansin sila na merong alteration with their sensation, or meron bang palpitations, okay, if ever lang. Okay, you have to constantly ask these patients. Treatment over photosensitive areas. Treatment of patient with epilepsy. Okay, because again, no, they are light-sensitive people. Okay, treatment of skin with altered sensation, no? So, impaired sensation or altered sensation. Ayan. Cognitive difficulties or unreliable patient, no? Impaired mentation, okay, precaution siya. And epiphyseal plates in children. So, before, di ba, you have asked kung meron bang age limits IRR. Wala po. But with your laser, no, you have to be precautionary with the epiphyseal plates in children. No? Kasi you might cause yung closing of the epiphyseal plates. Okay? So, as much as possible, you stay away from the epiphyseal plates. If you have pediatric patients. Okay? So, siguro naman, no, with basic anatomy, alam na natin kung nasaan ang epiphyseal plates, no? Nasa dulo ng mga long bones. Okay? So, ayan. Alright, so that would be it for our laser discussion. Okay? So, review. And we'll have the post-quiz 30 minutes before the end of your session for today. Okay, good luck. Thank you.